The root of many struggles in mathematics is a poor conceptual understanding of the ideas being considered. This works all the way back to arithmetic. The goal of this section is to introduce, or reintroduce, the concept of the number line. We will be using this picture throughout the curriculum, so even though it may seem very simple, it is a vitally important concept to master. The number line is a picture that puts all of our numbers in a specific order. The values increase as we move to the right and decrease as we move to the left. We can start with the number 0 and start labeling numbers as we move to the right. 1, 2, 3, and so on. The numbers to the right of 0 are called positive numbers. These numbers are called integers. There are other numbers that fall in between these, such as fractions, decimals, and more exotic numbers like the square root of 2 and pi. But for now we will focus on the integers. The numbers to the left of 0 are called negative numbers. We can count backwards from 0 to get these numbers: -1, -2, -3, and so on. We will come back to these later in this chapter. Addition is the most basic operation on the number line. Conceptually, this is nothing more than counting. Example: compute 4 plus 7 using a number line. We will start by drawing a number line. Addition problems on a number line start from 0. This is known as the origin and represents the place from which all of our calculations will originate. 4 plus 7 is computed by starting from 0, moving 4 spaces to the right, and then 7 more spaces to the right. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. The answer is our location at the end of the movement. In this case, we can see 4 plus 7 equals 11. 4 plus 7 equals 11. In this calculation, we call the numbers 4 and 7 addends, and the result of the calculation is called the sum. People won't often talk about the addends, but you will need to know that the sum is the result of adding numbers together. This method of counting is good when the numbers are small, but as the numbers get larger, this becomes very inefficient. To get around this, we can count by multiples of numbers other than 1s. For example, we can draw a number line using multiples of 2, multiples of 5, or multiples of 10. In fact, we can use multiples of any number we want. At this point, it is important that the sizes of the steps are always the same. In other words, do not have some steps that are size 5 and other steps that are size 10. Example: compute 30 plus 20 using a number line. If we count by 1s, this problem will take a very long time. Instead, we will use multiples of number that work well with the problem that we've been given. In this case, 10 works very well. We will write out the first several multiples of 10 and then do the calculation. Starting from 0, we move 30 to the right, and then 20 more to the right. 10, 20, 30. 10, 20. And we can see that the answer is 50, so 30 plus 20 equals 50. Pay attention to the presentation of these two examples. We drew a number line and showed the steps with arrows. Then we wrote a complete mathematical sentence under the number line and put it in a box. How you write impacts how you think, and so by getting into the habits of good presentation early, you are helping your mind to prepare for the things that are coming. We will do one more example. Example: compute 25 plus 15 using a number line. What number works well with both 25 and 15? 5 does. So we will draw the number line using multiples of 5. Starting from 0, 5, 10, 15, 20, 25, and then 15 more, 5, 10, 15. 25 plus 15 equals 40.